we will talk about the preparation of alkyl halides via the CO bond cleavage of ethers. Okay. Now ethers have a general structure like this, where two carbons uh, are surrounding an oxygen atom. Okay, like whenever we can compare this with this water molecule, okay, where you have two hydrogens. In place of two hydrogens, the two carbons are actually there, not carbons, two alkyl groups, or one alkyl group, one aryl group, anything. Okay, it can be there, it can be like this, it can be a benzene group along with an alkyl group. Okay, so this is known as phenyl alkyl ethers. These are alkyl ethers, dialkyl ethers. So we will prepare alkyl halides by breaking these CO bonds. Okay, by breaking any of the CO bonds. To break this for the cleavage, we need a reagent. So the reagents are basically, you can use HI, most useful reagent, HI, or HBr, or HCl. It can be used, but HI is highly preferred over any of the other reagents. Then HBr, then HCl. So if you ask me why, because HI is most acidic between these hydrohalic acids. Why? In the previous class, we have also discussed, and even in chemical bonding, we have discussed that if you have mismatching of orbital sizes in a covalent molecule, then the bond strength decreases. So HI has very minimum, means, sorry, you can say HI has a large difference between their orbitals. Okay, so as they have large difference between their orbitals, their bond strength is least, and that is why their breaking will be the highest order. The breaking of this HI bond will be of the highest order, and as the bond breaks, the more number of H plus ions comes out, the more acidic the molecule becomes. Okay, so here HI is mostly used to cleave this CO bond. Now, I have two groups, one R group, oxygen, and one R dash. Here, oxygen has the lone pair, and this oxygen hybridization is sp3. Now, whenever you are using H plus of any of these acids, so this lone pair will actually make a coordinate bond to this H plus, and like H3O plus formation, you will see this type formation, ROR dash H plus, and this positive charge will move from this hydrogen to this oxygen. Okay, it will look like this, but it is actually a coordinate bond. Okay, it is actually a coordinate bond. It will look like this. And in books or in other websites, you can see that it can be written like this with a positive charge here. Okay, overall positive charge it is shown. So this is not a single bond, this is a coordinate bond, and we all know that coordinate bonds can be transferred or can be changed to a single bond if we break some other bond. So this is the structure of this cation, which is formed by the action of H plus on this ether. Now, whenever you are using I minus, this I minus will react with this intermediate cation from backside. Okay, that means this I minus will attack via SN2 pathway. So the attacking pathway is SN2. Now you have RO, R dashed, H, and a positive sign. Okay. In SN1, in SN2, we have seen that the alkyl groups, the lower its degree, the higher is its reactivity. So if between R and R dash, if you see that Ri is being formed, and as Ri will be formed, ROH will be, R dashed OH will be its side product. That means cleavage of ether will give you an alkyl halide and an alcohol. So if you see this, then you will say that this R group is of lower degree than R dashed. If both are same degree, so if both are 1, both are 2, then equal formation means 50% Ri, 50% ROH will be the formation. But if one is 1 degree and the other is 2 degree, then the difference will be there. Okay, R 1 degree will preferentially form Ri, means the percentage of Ri with 1 degree will be higher than 2 degree. Means let me show you. Suppose R is 1 degree and R dashed is 2 degree. Then we will get Ri as the major product. Okay, and R dashed I as minor. Okay, along with R dashed OH and R OH. So this part is mostly not used in showing the reaction, but they are feebly present because we cannot outweigh the whole reaction as a whole. But for the exam, you need to understand that whenever we are writing in exam, we need to focus on the product that has maximum yield. So means the one who is produced in the maximum amount. So here Ri will be your major product from here, not R dash and ROH. So for the exam, you will have to understand that we will remember this part, Ri and R dash to H, when Ri is 1 degree and R dash is 2 degree. Now, if R is 2 degree and R dash is 3 degree, then what will happen? Then you will find R dash I is forming as a major product along with ROH. Now you will say that you are contradicting your own statement. You have said that R dashed, if it is of lower degree, then R will form, iodide will form via the SN2 atom. Actually, the formation of carbocation intermediate that is formed here R, O, R dashed and H. This intermediate carbocation that has been formed here, if one is 3 degree, then it will move out of the system because it has higher stability. We have learned through the stability number line that the 3 degree carbocations are most stable, and that is why it will move out of the system. Okay, because of their higher stability, they will tend to move out from the system. That is why as they have moved out from the system, this intermediate will be very short-lived. Okay, this intermediate will form, but their their time frame of existing will be very less. Okay, just you can take the instance, or you can take the citation of the Super Saiyan God that what is his name? Shenron was explaining to the crew of the Saiyans, Goku, Vegeta, and others. So because they asked him that is there someone present like that, and they said yes, they exist, but they exist for a very short time, and again they moved out from there. Here also the same thing will happen. This will form, but because of the higher stability of this carbocation, this ROH will be formed and R dash plus will move out of the system. And this R dash plus will react with the the I minus formed by due to the dissociation of HI, and it will give you the R dash time. Okay, that is why whenever you have a 3 degree alkyl group, the preferential formation of this iodide will be there. Okay. Now, so it is clear that if you have CH3O, C2H5, and if you are giving HI, then you will get CH3I along with C2H5OH. Okay, this is 1 degree, this is 0 degree. Now, if you have C2H5O, C, CH3, 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 and you are giving HI, then you will get CI along with CH3 or whole 3. Okay, or I can write it like this, that you will get CH3, 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 I along with C2H5OH. Okay, because this is 3 degree. This is the 3 degree one. This is 1 degree. This is also 1 degree. This is 0 degree. So when there is 1 degree and 2 degree, so between 0 degree, 1 degree and 2 degree. 0 degree is actually methyl. Okay, methyl 1 degree and 2 degree. Always they prefer, but if they are comparing, then CH3 will be preferred over 1 degree and 2 degree, like this. But if there is 3 degree, then 3 degree will be preferred because it will not come in competition. It will just move out of the system and stand alone and react with iodide. One more type of ether that we have discussed here is phenyl ethers, like OCH3 or anything. Now, when you are using HI, same thing will be formed here. Same thing will be formed. OCH3, H, and this intermediate cation will be there. Okay. Now, whenever you are giving I minus, here SN2 or SN1, any pathway they can follow. Here the R group is irrelevant of any of the R group present, because I minus can never attack this benzene group. Okay, because this is electron rich species and I minus is also an anion electron rich. So there will be a difference. Sorry, there will be a repulsion between electron and electrons. Electron rich iodide, when it comes in vicinity of this pi electron rich species, it will get repelled, and that is why it will always attack this alkyl group. Okay, regardless of it is 1 degree, 2 degree, 3 degree, any degree, anything it is there, if it is not a benzene group, then it will react with like this. Okay, so if I have diphenyl ether, then I cannot get the iodide from there. Okay, because iodide cannot attack it from anywhere. So this is also used in the preparation of phenols from any methyl ethers. Okay, methyl phenyl ethers, any methyl phenyl ethers, if you use, you will get this phenol from there. So preparation of phenol can also be understood from this part. So this is it. In the next chapter, in the next part, we will learn about the other reactions, chemical reactions of alkyl. So till then,